Hey everyone, I'm Ashley and I'm here with Emily and we're the Engineering Chicks. And today we're just going to be giving a quick demo of our final project for our digital simulation class. This isn't quite complete, it's just kind of an update on what we're working on. So basically we're trying to simulate some financial data for put options. So with those, it's an option and you have the right to sell it. So we're going to be focusing right now on American style options, which you can sell at any time. So we have 3 different policies that we want to test to see which policy gives us the higher chance of making the most money. So policy 1 states that we're going to sell the option if the option price increases more than 25%. And then policy 2 is if the option price decreases more than 10% from the highest value it has ever reached, then sell the option. And then policy 3 is to sell the option on the expiration date of the option, which is just practicing European style option sellings with an American style option. So for one of our previous homeworks, we had to simulate geometric Brownian motion, and that is often used to simulate the stock market. So that's what we're going to use here. We also borrowed this mu and sigma from the previous homework, and the mu is growth rate and sigma is volatility. And we might change that. We're going to maybe do some more research on kind of what would maybe be standard for these. But for right now, this is what we're going to leave it at.
So now I'm going to take you through the code that we've developed so far for this problem. And right here, we're just initializing values. We picked $100 as our initial investment, just because that's just a number that we decided right now. It's probably going to change, so that's like the option worth right now. But we'll probably play with it a little bit more. And then, so coming through the code, we've got all of our initializations at 0 and stuff. And then we've got this information from the Brownian motion. And then, so we start our for loop. Right now we're just doing like one iteration of it, but to do more of a Monte Carlo approach to it, we're going to bump this up to like n equals 1,000 maybe to get the average day that it sells on and the average amount of money that they make off of each of the different policies. And so our first one is policy 1. So this is for a whole year, and here's the Brownian motion part of it, and this is calculating the amounts of money that the stock goes through. And then we have this if statement for our policy. So it's saying that if the p-value, so the value of the stock market, is greater than or equal to 25% of the investment plus the investment, so 25% more than what was put in, then it's going to sell it. And this just keeps track of making sure that it just goes for that one iteration. We were having troubles with the if statement, and it would collect all of the ones that were greater than 25% of the investment, but we only want that first one because they're going to sell it at that point. And so then this statement right here keeps track of the day that it's sold on for each iteration. Coming down, policy 2, right now we haven't got this to work 100%, but the logic is there. So again, we're calculating the Brownian motion values for the stock market, and then we're saying that with this one, we want it to capture the greatest value out of all the past values, and say if the next value is 10% less than the most value, then we want to sell. So we're having a little bit of issues here with the if statement, but with a little bit more work, we're going to be able to detail that out and refine it so that it'll actually portray what we want it to. Again, this is capturing the day that it sells on, so that we can keep track of those. Then with policy 3, which if you recall, this is our policy that's basically just a European put. So it's selling on the last day of the year, or the last day expiration date, which we've decided to be like 1 year. And so with this one, it's just going through and calculating the Brownian motion for the entire year, and then it's the last value. So the last 3 p-value is the policy 3 amount. And then for this one, it really doesn't matter. We're keeping track of the days because it's always going to be on the last day. So day 365. Down here, just doing some summary statistics. So the P1 selling value, P2 selling value, and P3 selling values. And then the average of the selling day. And then the average money made using policy 1. So we're just taking the P1 selling value, subtracting the investment from it, and getting that actual average money made. So going off of this summary statistic, we'll make our conclusions of which policy is in fact better for giving you the most bang for your buck, if you would like to say. So I'll go ahead and run this so that we can just show you what we've got so far. It does take a minute. Okay, so here we go. As you can see right now, it's 3 different generations of the Brownian motion. We're going to see how this approach works. If not, we're going to try to combine it to going all off of one simulated geometric Brownian motion. So all of them will be standardized off of that one generation, and we'll do iterations off of the one geometric Brownian motion. So as you can see, let me pull up the results. Right now, we do have this undefined P2 selling value. That's the issues that I'm having with policy 2 that I talked about. But you can see that, we'll go through the amounts. The P1 selling value right now is 130, and then the P2 selling value is 0 just because it's not quite working right yet, and then the P3 selling value is 85. And when we look at this graph right here, we can see that let me make sure that I have the graphs correct. So policy 3, that's this burgundy or red line. And so you can see that it's only making, you're actually going to lose money because your initial investment was the 100. So you're actually losing money if you sell on this last day. With the other 2, even though the code isn't working, the graph is still correct. So with policy 2, that's the blue curve. So as you can see with this policy, so when it drops that 10%, they're going to immediately pull out. And so you can see that probably it would be somewhere around in either this area or right here where it does drop that 10% from the max value, and they're going to pull out. So they're going to really lose on their investment because once it gets farther up here, it takes off and kind of grows really well. And then as for the one with policy 1, for the selling it as soon as it reaches 25% more than the initial investment, you can see it might have reached it right here. So you probably sold out before you were able to gain this arch right here. So I'm not 100% sure from the looks of the graph right here. I guess we can check the selling value. Let's look. So for P1, that's 130. So it was around in here was when it was sold. So they missed out on the opportunity to see it grow more. But this is kind of where we are right now with the project. We still have to calculate the probabilities with making average statistically more money with American puts or European puts. We still have to do that part, but we've gotten a pretty decent start with the policies and we're liking the results of it. So thank you for watching this video and stay tuned for more updates on our project.